Good morning, my dear friends. See now, we shall begin with incense. Now, in the last class, we have seen that the loss of pre-stress will occur in three different stages. Okay, loss of pre-stress during tensioning stage, loss of pre-stress during anchoring stage, and losses occurring subsequently. In the sense, as the time pass. So now, under this, during tensioning operation, the first loss is loss of pre-stress due to friction. So what exactly this is and how this loss takes place, we will try to see now. In a sense, loss of pre-stress due to friction, we will try to see now. See now, loss of pre-stress due to friction means, Baba now, I will explain you with a simple sketch now here. Please see now. So now you know that here is a pre-stressing beam. Oh sir, no? Assume that you have left a duct here now. This is the duct, whatever I have marked here now. So after leaving the duct in the formwork, you have poured the concrete here now, and the beam has been now casted. So now after this concrete has attained its full strength, now what you are going to do is now you are going to pass a cable here now. Pass a cable into the duct, then you are going to tension this cable, okay, tension this tendon or cable, and then anchoring it. Am I right, sir? No. So but now what happens is now, whenever you are tensioning this cable, what may happen is now, this cable may touch the top or bottom surface of your duct, okay, and there may be some friction, okay. There may be some friction between the cable and this duct. This friction will cause some loss. Am I right now? This is what we call it as the frictional loss, okay, the loss due to friction. See now, what happens is now, in a sense, sometimes, in sense now, assume that this cable is now fixed by some jacks. Am I right now? The friction may occur in the jack also now. The friction may occur in the jacks also, here and here, okay, because these cables are very tightly held by your jacks. Am I right now? Very tightly. Then it is going to apply the tension, okay. So but now, even some friction may occur in the jacks also now, but that is very small, so it can be now neglected, okay. But the frictional losses which are occurring along this duct becomes very important, and this loss is a major loss. This has to be taken into account, okay. So now, see now, actually, in sense now, whenever I want to now lay down this duct, okay, there may be certain amount of variations caused by the vibrations or constructional methods in the actual alignment of the duct. See now, what happens is now, whenever I'm forming this cable, okay, there may be some vibrations or constructional defects and all, okay. So the alignment may go wrong, okay, and one more thing, what may happen is now, this duct, okay, whichever I have now here, this duct, whichever I have now here, it has got some seriations or wobblings, okay. This duct is not perfectly smooth. Okay. It has got some undulations, like this. Undulations are there. Undulations are here also now. Undulations are now here now, okay. These undulations are called wobblings. They are called wobblings, okay. So these wobblings or undulations may cause some loss of pre-stress, okay, and this loss of pre-stress is called wobbling effect, okay. Whenever you are passing this cable, okay, into the duct, okay, and you are tensioning the cable, okay, at that time what may happen is now, these wobbling or these undulations may touch the cable, and they may increase the frictional loss, okay. This is what happens in case of your this thing now, or while the pre-stressing operations are now going on, okay. In sense, Baba, this wobbling effect, whatever we said, this loss is called wobbling loss, or it's also called length effect also now. Sometimes it is called length effect or wobbling effect. Okay, sir, now? So, but now, this wobbling loss will occur either in the straight cables, okay, in sense the cable may be laid straight or it may be laid curved like this now. Sometimes, in case of your continuous beams, oh sir, now the cable may be laid like this, because I said you that a cable profile must follow the bending moment pattern, bending moment diagram pattern. Okay, if you see the bending moment diagram pattern for a continuous beam, it is like this. Bending moment pattern is like this. Okay, that's the reason why I have laid the cable in case of your continuous beam something like this. From here to here, it is curved. Again, it is now going up. Again, it is coming down like this. Okay, this is the effective cable profile in case of your continuous beams. Am I right now? Or if it carries a UDL like this, okay, so now the cable, the best cable profile is parabolic, because bending moment profile, bending moment diagram for this UDL is now parabolic. Okay, so now, but this wobbling effect will occur whether the cable is straight or curved like this. It will occur. Okay, sometimes whenever I have laid the cable in this parabolic way or in a curved fashion, Baba, curvature effect also will cause some loss. Curvature effect. Okay, sir, now this curvature may lead to some loss of pre-stress. Okay, so now frictional loss may be of two types. One is, okay, one is the length or wobble effect. Okay, the in sense the frictional loss may be due to length or wobbling effect, and the second one, Baba, is due to the curvature effect. Due to the curvature effect. These are the two things. Curvature effect will come only when the cable is curved like this. Okay, and wobbling effect will come in straight cables as well as in curved cables. Okay, that's the thing now. Okay, now we'll try to see now how exactly this curvature, excuse me, how exactly this wobbling loss can be now calculated. We'll try to see now. Baba, your instance now, some of the theories say that, oh sir, now, if at all, say take for example, now I will give you one example. Assume that in this concrete, in this PSC beam, the cable is laid like this. Assume that it is laid like this. Okay, now I have applied a precessing force of P naught here now. Assume that I have applied a precessing force of P naught. Now I want to measure at some cross section XX the value of Px. In a sense, how much is the precessing force available at this cross section, which lies at a distance of x. Okay, see now, Px can be calculated by P naught into e to the power of minus kx. E means, as you know by now, it is exponential or base of natural log. Okay, exponential minus k times x. But now, where x is the distance at which you are measuring the precessing force, x. K means, Baba, it's called wobbling coefficient or wobbling constant. Baba, usually it will be given in the problem how much is the value of K. Okay, so that we'll see it little later, how much is the value of this K approximately. Okay, so from this I can easily calculate how much is the precessing force at this section. Suppose if at all I want to find out the precessing force here now. Okay, precessing force here. X increases. As X increases, Baba, loss also will increase. Loss also will increase. Am I right, sir, now? So now, for this wobbling effect, okay, this is the equation to find out the losses. Or the, if at all I want to find out the precessing force here, I can find out from this equation. Px is equal to P naught into e to the power of minus kx. Okay, this is one thing. And now, usually, now coming to this curvature effect, coming to this curvature effect, because of this curvature effect also, as I said, okay, whenever I am pressing the cable, the cable is going to exert the pressure on the duct, okay, and this curvature, again some friction will occur in this duct, okay, and because of this friction, okay sir, now and because of this curvature effect, okay, some loss will happen, okay. So now again, if at all I want to find out how much is the precessing force at this point or at this cross section, which is at a distance x, because of this curvature effect, it is given by px is equal to p naught into e to the power of minus mu alpha, okay. Again, p naught is the initial precessing force applied here now, and e is exponential, mu is, it is the coefficient of friction between the duct and the cable. Mu is the coefficient of friction between the duct and the cable, okay. And alpha means, it is the total change in the angle. Suppose now this is the cable which has been laid with some curvature, okay. I am going to draw the tangent here, and this is your alpha, total change in the angle, okay. So this is your alpha, okay. So this equation will give me the curvature effect, okay now. And if I want to combine these two, if at all, because whenever the cable is laid curved, both wobbling effect also will be there, and as well as the curvature effect also will be there. So when I add these two, I will get this equation, px is equal to p naught into e to the power of minus mu x plus kx, okay. If I add these two, I will get this. This equation will give me the combined effect of this thing now, combined effect of curvature as well as wobbling, okay. So now from this equation, a small derivation will give me the loss of pre-stress. If at all I want to find out the loss of pre-stress, it is mu alpha plus kx into initial pre-stress, okay. Mu alpha plus kx, mu you know, it is the coefficient of friction between the cable and the duct, okay. Alpha is the total change in the angle, alpha, okay. K is wobbling coefficient factor, and x is the distance between where I want to now measure this thing. This equation will give me the loss of pre-stress. This initial pre-stress means how much initial pre-stress you have applied here now, okay. So now from this you can easily see that as the distance goes on increasing, okay, the loss of pre-stress also will increase, because as x increases, loss will increase. As mu increases, the coefficient of friction increases, loss will increase. As alpha increase, as this total change in angle increases, this loss of pre-stress will increase. As k increases, this loss will increase. Understood or not now? So now on all these factors, this loss of pre-stress due to frictional loss will depend. That's why now to compensate this loss, what they do is now, okay, to reduce this mu, they will put some oil in the duct, okay. During the pre-stressing operations, they will put some grease or oil in the duct, so that mu can be reduced and this k can be reduced, okay. And but now alpha can be now reduced by keeping in sense now curvature should not be too high, okay. By reducing the curvature also, I can reduce this loss of pre-stress. Am I right now? And it is always better to pre-stress the cables from both the ends, because if at all you want to measure the loss of pre-stress at this end by tensioning from this end, x is this much, then loss of pre-stress will be very, very high. So what I do is now pre-stress from this end also and pre-stress from this end also. In a sense, jacking from this end and jacking from this end, both the ends will minimize this loss. Okay, this is how the loss of pre-stress due to friction can be now reduced. Okay, thank you very much, my dear friends. Thank you.